Okay, Assalamualaikum dan salam sejahtera. Saya Madam Hafizah, pensyarah unit Fizik Kolej Matrikulasi Pulau Pinang. So, pada hari ini saya akan share mengenai chapter 7. Part A kita tengok geometrical optics saja untuk pelajar VIP classroom lah. Alright, before we go through the question, kita tengok dulu list of equation that we can use in 7a, which is geometrical optic. The first equation is R equals to 2F. And next is 1 over F equals to 1 over U plus 1 over V. Then M is equals to HI over H naught, and also equals to negative V over U. So untuk the first equation, R equals to 2F, this equation only valid for mirror only. Where R is the radius of the mirror and F is the focal length of the mirror. So R ini, dia depends pada mirror lah, which is if the mirror is concave mirror, the R and F will be positive. If the mirror is a convex mirror, the R and F will be negative. Alright, so for the second equation, focal length. Saya dah mention dah tadi, focal length untuk concave is positive and then focal length for convex is negative. U is the distance of the object from the pole of the mirror. And then V is the distance of the image from the pole of the mirror. So untuk U ni, normally our object is located in front of the mirror lah. So untuk V, dia punya untuk V, V itu positive if the image is located in front of the mirror, ataupun normally we call as the real image. So mirror adalah konsep reflection. Mirror adalah konsep reflection. So jadi bila image tu form in front of the mirror, so dia adalah real image. And you have to remember that bila dia real image, dia juga adalah inverted. So please remember IR. So maksudnya dia adalah real image and also inverted. So if you calculate and then you get V equals to negative, or the question mentioned to you, the virtual image. Virtual image. So meaning that when an image is virtual, dia adalah another characteristic of the image is upright. So please remember UV. So UV ni singkatan. Untuk you remember, for virtual image dia juga adalah upright. For real image dia adalah inverted. That one is for the second equation, the sign convention. We look at equation 67, which is magnification. Untuk real image, untuk real image, HI akan jadi negatif. Kenapa negatif? Because of real image dia inverted. Sebab tu saya suruh you ingat IR. Bila real image dia akan inverted. Kalau you punya image tu virtual, bila image tu virtual, dia akan jadi, HI tu akan jadi positif. Kenapa HI tu positif? Because dia virtual dan upright. That's why I ask you to remember IR and UV. It's easier for you to remember the sign convention for height of the image. Kalau height of the object, normally our object is upright. So jadi height of the object will be positive, always positive. And then untuk equation negative V and negative V over U, so use back the relationship yang ada kat sini. Use back the relationship V positive for real image and then V negative for virtual image. And then how about the magnification? So untuk image yang real dan inverted, image yang real dan inverted, so the magnification will be negative. Okay, magnification untuk image yang real dan inverted, the magnification will be negative. Okay, so you kena ingat ini untuk IR. Okay, kalau you dapat magnification positive, okay, dia punya value tu positive, meaning that the image is upright dan virtual. Okay, please remember this one. Okay, and then when the magnification, okay, is equals to 1, okay, normally is a negative 1, dia tak ada positive 1. Okay, when the magnification is equals to 1, meaning that the image is same size with the object. Okay, and then when you get the magnification is more than 1, okay, the value is more than 1, okay, so meaning that the image is magnified. Okay, and then when you get m is less than 1, okay, when the magnification is less than 1, maksudnya image tu diminish. Okay, so nanti bila kita kira, okay, so you akan dapat contohnya the magnification is equals to negative 5. Apa maksud magnification negative 5? Okay, negative ni refer to inverted. Okay, negative ni refer to the inverted, and 5 refer to magnified. Okay, please remember that. Okay, negatif dengan nombor 5 tu kita baca secara berasingan. Alright, so we go through the first equation. Okay, we go through the first question, not first equation. Alright, so the first question, okay, so saya ambil soalan 1A. Alright, so the first question 1A, okay, an object 4 cm height. So this is the height of the object. Okay, it's placed 15 cm from convex mirror. Okay, don't just look at 15 cm. You have to look also the convex mirror. Okay, of focal length 5 cm. Alright, so this way you determine, okay, the position of the image from the mirror, the magnification of the image, and the height of the image. Alright, so kita keluarkan information given dulu. Okay, so the first information given, okay, so the first information given, you are given the height of the object, which is equals to 4 cm. Okay, so the second information given is object is placed 15 cm from convex mirror. So meaning that 15 cm. Okay, and then you are given here a convex mirror. So bila convex mirror, the focal length is equals to negative 5 cm, not positive. Right, that's why I asked you to remember the sign convention of the focal length of the mirror. Okay, so now kita nak cari the position of the image from the mirror. So according to the information given here, okay, you nak cari V. Okay, you nak cari V, so we can use 1 over, okay, I ada sediakan list of equation dekat sini, so you can refer the equation that you suitable for you to calculate the position of the image, okay, with correspond to the information given. Okay, so now we'll use the equation 66, so 1 over f equals to 1 over u, okay, plus with 1 over v. Right, so substitute 1 over f, which is negative 5, equals to 1 over u, which is 15, plus 1 over v. Alright, so here you will get the value of v, the image distance, okay, from the mirror is negative 3.75 cm. Okay, what is the meaning of V negative? Okay, as I mentioned before, V negative maksudnya dia adalah virtual, okay, virtual image. So bila virtual image, okay, so pasangan dia adalah upright. Okay, pasangan dia adalah upright. Sebab you nak cari nilai magnification. Okay, so magnification you, okay, mesti kena dapat nilai yang positif. Sebab apa? Magnification yang positif adalah untuk upright image. Okay, so let's find the value of magnification. So I want to use the equation 67. Okay, so magnification is equals to negative V over U. Okay, because I have the value of V and I have the value of U. Okay, so I substitute here negative 3.75, okay, divided with U is a 15. Okay, so here I will get the value of magnification is positive 0.25. Okay, apa maksud positive 0.25? So positive maksudnya dia upright. Okay, you get the positive value meaning that dia upright. Upright is a virtual image lah. Okay, then you get 0.25 which is the value is less than 1. Bila less than 1 maksudnya dia diminish. Okay, so you have to remember this one. Okay, next. You want to find the height of the image. So bila you dah tahu dia diminish, okay, you dah tahu dia diminish, so jadi height of the image will be less than height of the object, which is height of the object is 4 cm. So kita cari the value of height of the image by using the equation 67 juga lah. Okay, magnification equals to hi over h naught. Okay, you already have the magnification 0.25 equals to height of the image we want to calculate, and then height of the object is 4 cm. Okay, we will get height of the image which is equals to 1 centimeter, which is 1 centimeter is less than the height of the object. Okay. Okay, for the next question, okay, I choose 7a. Okay, so look at the information given here. Okay, an object is placed in front of a concave mirror. Okay, it's a concave mirror with 25 centimeter radius of curvature. So this is the value of R. Okay, and R is positive because of you are given a concave mirror. And then a real image twice the size of the object form. Right, so the image is real image. Okay, now we check out all the information given. So you are given, okay, you are given the radius of curvature which is equals to 25 centimeter. So from here we can find the focal length of the mirror, of the concave mirror, which is equals to 12.5 centimeter, which is half of the radius of curvature. And then you are given the real image. So you are given the real image. So now the magnification, okay, because the real image is twice the size of the object form. Okay, so the magnification is 2, but not only 2. Okay, because of bila dia real, okay, dia akan inverted juga. So the magnification is negative 2. Okay, not only 2. Okay, so now you kena sketch a ray diagram to illustrate the formation of the image. Okay, so saya tunjuk ringkasan sikit kat sini. Alright, so this is a position of the mirror. Okay, this is the concave mirror. Okay, this is the focal length, and then this will be the center of curvature. The center of curvature is twice the focal length. Okay, alright, so now if the object is located, okay, more than the radius of curvature, maksudnya kedudukan dia lebih daripada C, C dan ke belakang, dia duduk di belakang C. So if the position of the object dekat sini, so image yang terhasil is diminished, inverted and real. Okay, this is the short form untuk the characteristic of the image form. Okay, so saya buat ringkasan of the characteristic of the image. Alright, so if the object is located more than C, the image is diminished, inverted and real. If the object is located at C, okay, so image form is same size, inverted and real. If the object is located between C and F, okay, more than C and less than, more than F and less than C, so the characteristic of the image form will be magnified, inverted and real. Okay, if the object is located at F, if the object is located at F, the characteristic of the image form is at infinity. Okay, so if the object is located less than the focal length, okay, less than the focal length, so the characteristic of the image form is magnified, upright and virtual. Okay, ini adalah ringkasan karakteristik of image form untuk position 5 position of the object. Okay, so now untuk you punya soalan, Okey, untuk soalan you, image yang terhasil adalah image yang real. Okey, bila image yang real ada 3 position. Okey, yang more than C, at C, or between C and F. Okay, so antara 3 ni. And then the size of the object is twice, meaning that magnified. So bila magnified, okay, so the position of the object is between C and F. Okay, the position of the object is between C and F. Okay, so now you have to sketch the ray diagram to illustrate the formation of the image. Okay, so you can draw the principal line. Okay, so use your ruler, draw the principal line. Okay, make sure use ruler. Okay, and then draw the position of the mirror. Okay, let's say the dotted I represent the mirror. I tak lukis dia punya curve lagi. Okay, and then label C and F. Okay, this will be F, and then your C will be twice the length of the focal length. Okay, so now I letak object at this position. This will be the object. Okay, so use 3 ray. Okay, 3 ray yang diberi tu. Tapi you hanya boleh pilih 2 saja. Okay, use 2 ray. Okay, to sketch the formation of the image. Okay, the first ray will be parallel to the principal axis and then reflect to the focal point. Okay, parallel to the principal axis and then reflect to the focal point. Okay, and then the second ray will be towards the focal point. Okay, towards the focal point and then reflect parallel to the principal axis. Okay, tempat yang dia intercept ni, okay, will be the location of the image. This will be the image. So we can see here, okay, the image is magnified, inverted and real image. Okay, and then you lukislah dia punya mirror. Okay, which is a concave mirror. Okay, that one is for number 1. Okay, so number 2. Okay, determine the object distance from the mirror. So jadi object distance you mesti dapat lebih besar daripada 12.5. Sebab you punya objek, okay, duduk di antara C dengan F. So you punya object distance tu mesti lebih besar daripada 12.5 dan lebih kecil daripada 25. Okay, itu clue yang you ada lah. Okay, you nak pakai equation apa? Okay, because we have the magnification here. Okay, we have the magnification and we have the focal length here. Okay, so from that we can use, okay, the magnification equals to negative V over U. Okay, because we have a magnification which is equals to negative 2. So, V ni kita tak tahu. And then, U pun kita tak tahu. So, kita nak cari U kan. So, make it V as a subject. So, we get here V sama dengan 2 kali U. So, your V must be positive. Why? Because your image is real. So, V mesti positive. Okay, and then by substituting into the equation 66, 1 over F equals to 1 over U plus with 1 over V. Okay, so 1 over F, you already have the focal length here 12.5. Okay, sama dengan 1 over U, awak nak cari, plus dengan 1 over V which is equals to 2U. Okay, so here calculate U and then you will get U sama dengan 18.75 cm. So this value of U, okay, this value of U is less than the radius of curvature and more than the focal length. Okay, right? So valid dengan you punya ray diagram. Okay, next question is 8A. Okay, an object is placed 15 cm in front of the mirror. Okay, the image formed by the mirror, okay, is upright and magnified 2 times. Okay, so dia tanya, is the mirror convex or concave? Explain your answer. Okay, so awak kena faham kat sini. Okay, awak kena faham dekat sini. Untuk image yang upright, upright maksudnya dia adalah virtual juga. So, dua-dua mirror, concave dengan convex, dia akan produce image yang upright dan virtual. Tapi untuk concave, okay, dia akan produce image yang magnified. Okay, image yang magnified. Tapi untuk convex, image upright dan virtual itu adalah diminished. Okay, alright. So jadi bila dia tanya is the mirror convex or concave, so you kena cakap the mirror is a concave mirror. Sebab apa concave mirror? Sebab image yang terhasil tu magnified 2 times. You nyatakanlah kat sini because okay, the image form, okay, the image form upright and magnified. Macam tu. Okay, dia upright dan magnified. Kalau untuk convex, okay, dia punya image yang form tu upright dan diminished. Okay, itu yang pertama. And then yang kedua, so what is another characteristic of the image? Explain your answer. So the other characteristic untuk image yang terhasil tu adalah virtual. Okay, meaning that the position dia adalah behind of the mirror. Okay, behind of the mirror. Kenapa virtual? Because of the image is upright lah. Okay, bila upright dia punya pasangan adalah virtual. Okay. Next, dia suruh you okay, determine the radius of curvature of the mirror. So for you to determine the radius of curvature of the mirror, okay, awak nak determine the radius of curvature of the mirror, so awak kena cari dia punya focal length dulu. Okay, based on the information given to you, okay, so you are given the object which is equals to 15 cm. Okay, you are given the object which is 15 cm and then you also given the magnification which is equals to 2. Okay, so untuk yang magnification ni, okay, because dia adalah upright dan virtual, so jadi magnification dia adalah positive 2. Okay, so magnification is positive 2. Okay, so now to determine the radius, okay, how to determine the radius? So we have U, we have M, so we can choose equation 67, okay, for us to find the V. Okay, kita boleh cari V kat situ. So magnification is equals to negative V over U. So the magnification is 2, negative V over U is 15. So we get V here equals to negative 30 cm. Okay, so V awak kena dapat negative. Why negative? Because of dia image yang upright. So bila upright dia adalah virtual. So bila virtual, V mesti negative. And then by using 1 over F equals to 1 over U plus 1 over V. Okay, we can find focal length here. So 1 over U is 15 plus with 1 over V negative 30. So here you will get the focal length is equals to 30 cm. Alright, so dia adalah concave mirror kan. So bila dia concave mirror, so focal length dia mesti positive. So you want to find the radius. Okay, you want to find the radius which is equals to 2F. Okay, 2 kali 30. So you will get here equals to 60 cm. Alright, so focal length untuk concave positive, so radius dia pun positive. Okay, we move to the next part. Okay, which is refraction. Yang tadi mirror dia undergo reflection, pantulan. Okay, yang ini kita tengok bahagian refraction juga. So we have 4 selected equation here. Okay, the first one is N1 over U plus N2 over V equals to N2 minus N1 over R. Okay, this equation we use for spherical surface. Okay, spherical surface. Di mana N1, N2, and R kita determine by referring to the first object. Alright, we determine by referring to first object. Alright, so the next equation, equation 69. Okay, equation 69, 1 over F equals to N material over N medium minus 1 darab dengan 1 over R1 minus 1 over R2. Okay, this equation is a thin lens maker equation. Okay, lens maker equation is we use to determine the focal length of the lens, thin lens. Okay, because thin lens has two surface. So bila ada dua surface, dia akan ada R1 and ada R2. So we cannot simply use, okay, R equals to 2F. Okay, R equals to 2F for us to find the focal length of the lens. Tak boleh. This one, as I mentioned, this one is for mirror only. Okay, tapi untuk lens, okay, untuk lens we have two surface. Bila kita ada two surface, we have R1 and R2. Okay, that's why we, if we want to determine the focal length of the lens, we can use equation 69. We cannot use equation R sama dengan 2F. Okay, and then equation 66, 1 over F equals to 1 over U plus 1 over V sama macam mirror. Okay, cuma untuk lens, okay, F positif itu adalah untuk convex lens. Okay, jangan confuse dengan mirror. F positif is for convex lens ataupun kita panggil sebagai converging lens. Okay, so converging lens ada 3. Okay, by convex, convex meniscus dengan plano convex. Okay, tiga-tiga tu adalah convex lens dan dia adalah converging lens. Okay, focal length dia mesti positif. Okay, and then the second lens is concave lens, so the focal length is negative. Okay, untuk concave lens, okay, dia punya focal length is negative. Okay, dia adalah diverging lens. So kita ada 3 concave lens, which is biconcave, concave meniscus and plano concave. Okay, so tiga-tiga tu adalah diverging lens. Okay, and then U. Okay, U ni dia positif kalau dia located in front of the lens. Okay, in front of the lens, so dia positif. Kalau U tu duduk behind of the lens, dia akan jadi negatif. Okay, so U negative is when located behind of the lens. Alright, and then V. V positive. Okay, so ini jangan confuse dengan mirror. So V positive maksudnya dia located behind of the lens. Okay, sebab apa? Sebab dia adalah real image. Okay, dia undergo refraction. So bila refraction, okay, V positive meaning that dia berlaku, dia form behind of the lens. Okay, and then V negative maksudnya dia form in front of the lens. Okay, in front of the lens. Alright, and then sama juga. Okay, sama juga untuk magnification. Magnification sama macam apa tadi, mirror tadi. Okay, HI tu positive is for virtual image, HI negative is for inverted image. Okay, maksudnya dia terbalik. Okay, and then magnification positive is for virtual image. Okay, magnification negative is for inverted image. So nanti you refer balik pada mirror lah. Okay, alright. Okay, kita tengok soalan 8C. Okay, kita tengok soalan 8C. Ini adalah spherical surface. Alright, so I letak list of equation yang we can use untuk solve spherical surface dengan thin lens. Okay, alright, so look at question 8C. Okay, figure 6.2 shows an object and a glass rod immersed in a liquid. Okay, the rod has a refractive index 1.7. Okay, and a radius of curvature is 8 cm. So if the object distance is 15 cm, okay, and the virtual image distance is 13 cm. Okay, maksudnya image yang terhasil ni adalah image yang virtual. Okay, virtual maksudnya dia duduk same side with the object ataupun in front of the surface. So determine the refractive index of the liquid. Okay, refractive index of the liquid. Okay, tadi saya lupa nak cerita. pasal radius of curvature untuk concave dengan convex surface. Apa, sekejap lagi saya cerita. Okay, alright. So now you have an object here. Okay, so objek ini kita akan tentukan dia punya surface of the glass rod. Okay, so now sekarang ni, okay, this is the object. So this is the surface of the glass rod. Okay, so you kena label this one as front, this one as back. Kenapa kita label front back ni? So maksudnya front ni adalah untuk index of refraction yang pertama. Okay, back ni adalah untuk index of refraction yang kedua. Maksudnya, so saya tulis dekat sini. Okay, index of refraction yang pertama will be liquid, which is kita tak tahu liquid tu berapa. And then index of refraction yang kedua adalah glass rod, which is 1.7. Okay, and then the object, okay, duduk di hadapan surface tu, so dia punya U will be 15 cm. Okay, 15 cm, and V, dia dah bagi jarak image ni 13 cm kan. Okay, 13 cm dia kata virtual image, maksudnya dia duduk di hadapan. Okay, so dia punya V will be negative 13 cm. Okay, and then you are given also the radius of curvature. The radius of curvature of the surface sini. Okay, alright, so now the object is facing a concave surface. So bila object facing concave surface, so dia punya radius adalah negative 8 cm. Okay, kalau object tu facing surface convex, okay, surface convex, so jadi dia punya radius tu akan jadi positif. Okay, so yang ni you tolong ingat, tadi saya lupa nak bagi tahu. Okay, radius of curvature untuk concave surface negative, radius of curvature untuk convex surface will be positive. Okay, so now we use equation 68 lah. Okay, 68 N1 over U plus N2 over V sama dengan N2 minus N1 over R. Okay, so substitute the value. N1 kita nak cari, kita tak tahu lagi index of refraction of the liquid, and then U adalah 15 cm. Okay, plus dengan N2 is 1.7 over V is negative 13. Okay, V is negative 13 equals to N2 will be 1.7 minus dengan N1 over dengan, okay, the radius of curvature is negative 8. Okay, so from here you can get N1, okay, you kira baik-baik, kena kira baik-baik. So you will get N1 equals to 1.41. Okay, so the liquid punya index of refraction is 1.41. Okay, next question. Okay, soalan 9B. Alright, soalan 9B. Figure 6 shows a long road with a convex surface of radius of curvature 6 cm. Okay, at one end, and is made from glass with refractive index 1.60. Okay, the glass rod is placed in the water with refractive index 1.33. An object placed along the road axis is to be imaged 53 cm inside the rod. So calculate the object position. Okay, so according to the information given here, okay, so the object is located, okay, in front of the convex surface. So ini convex surface, so ini akan jadi front, ini akan jadi back. So meaning that kita punya N1, okay, N1 kita adalah water 1.33. So dia punya index of refraction yang kedua adalah glass, which is 1.60. Okay, alright. Then kita nak cari object position, maksudnya U kita tak tahu. Our V, okay, dia kata 15 cm inside the rod, maksudnya opposite side with the object, so maksudnya dia adalah real image. So jadi dia punya V tu adalah positif 53 cm. Alright, and then the radius of curvature, dia bagi radius of curvature 6 cm. So now saya kata tadi bila objek tu facing surface convex, so R dia akan jadi positif 6.0 cm. Radius of curvature dia akan jadi positif. Okay, so by using equation 68, so we substitute N1. Okay, kita tulis equation dulu. Okay, so N1 will be 1.33. Okay, our U is nak cari, plus dengan N2 is 1.60 divided by V, which is 53. Okay, equals to 1.60 minus dengan 1.33 divided by the radius of curvature is positive 6. Okay, so from here you will get the value of U sama dengan 89.8 cm. Right? Okay. Okay, habis untuk spherical surface. Now kita nak guna equation 69. Okay, untuk kita cari focal length of a thin lens. Okay, bukan lagi spherical surface lah, kita nak tengok untuk thin lens pula. Okay, so now soalan 4A2. Okay, figure 1 shows a converging lens made of material with refractive index 2.26. Okay, this is the refractive index of a lens given, and then one of the surface of the lens is plane and the other has a radius of curvature 24.5 cm. Okay, so kita nak determine the length of the focal length. Okay, so now 2.26 tu adalah, okay, so we take out all the information given here. So 2.26 tu adalah N material, index of refraction of the material, which is 2.26. Okay, and then let's say this one is the first surface and then this one is the second surface, and the object is located facing the first surface. Okay, so object yang facing R1 ni, okay, R1 tu adalah plane. So bila plane dia adalah, radius dia adalah infinity. Okay, for R2, the object is facing a concave surface. A concave surface, so jadi bila dia facing concave surface, so dia punya radius of curvature will be negative 24.5 cm. So by using 1 over F, okay, is equals to N material over N medium. So substitute the value. N material is 2.26. Okay, so dia tak bagi tahu lens tu located dekat medium apa. So jadi maksudnya medium udara. So 1.0 minus with 1 darab dengan, okay, 1 over R1 is infinity minus with 1 over R2 is negative 24.5. Okay, so here you will get the focal length is equals to 19.4 cm. Okay, not 11.6 cm, bukan 11.6 it's 19.4 cm. Okay, but if we put the object facing R2, okay, jadi bila objek duduk kat sini, so dia bukan lagi R2, ini akan jadi R1. Okay, yang ini akan jadi R1, yang ini akan jadi R2. Okay, kalau saya terbalikkan so jadi you punya substitution dia akan jadi 1 over F equals to 2.26 over 1.0 minus 1. Okay, so R1 you akan jadi surface convex, so which is 24.5, and then minus with 1 over surface yang kedua tu adalah plane, which is infinity. Okay, so dekat sini you tetap akan dapat dia punya focal length 19.4 cm juga. Dia takkan bila you tukar position of the object tiba-tiba you akan dapat focal length negative, no. Okay, because that one is a converging lens. So bila converging lens, focal length dia adalah positif. So any position of the object you letak dekat mana pun you tetap akan dapat dia punya focal length which is positive, right? Okay, for the next question, okay, 8B. You are given, okay, you are given shows a lens with radii of curvature 15 cm dengan 15 cm and 50 cm made of glass with refractive index 1.55. So determine the focal length and types of the lens. Okay, so sekarang ni kita nak okay, you are given ini lens ni, kalau kita tengok dekat sini dia adalah concave lens. Okay, so you kena hati-hati with the radius 15 cm dengan 50 cm ni yang mana satu. Okay, untuk concave lens, okay, radius yang paling luar ni, okay, radius yang luar ni, dia punya radius adalah 50 cm. Okey, yang bahagian dalam ni, okey, yang bahagian dalam ni radius dia adalah 15 cm. You tak boleh terbalik. Kalau you terbalik, dia akan jadi convex meniscus. Okey, yang ini concave meniscus. Okey, bila concave meniscus, radius yang di bahagian luar lebih besar daripada radius yang bahagian dalam. Okey, kalau you tertukar radius tu, dia akan jadi convex meniscus. Okay, alright. So and then you are given the index of refraction which is 1.55. Okay, so let's say the location of the object dekat sini. Okay, so given here, so the index of refraction of the material adalah 1.55. Okay, and then R1 will be 50 cm. Okay, and R2 will be 15 cm. Okay, disebabkan objek duduk dekat belah kiri ni, so jadi objek ni dia akan facing R1 which is a convex surface, which is positive 50 cm. Okay, and R2 also adalah convex surface. Okay, so dia adalah positive 15 cm. Alright, so we substitute into the equation of 69. So 1 over F is equals to N material which is equal to 1.55. Okay, divided with the N medium is 1.0 minus dengan 1. Okay, darab dengan 1 over R1. 1 over R1 is 1 over 50. Okay, minus with 1 over positive 15 also. Okay, 1 over 50 minus dengan 1 over 15. Alright, so you akan dapat the focal length dekat sini. Okay, sama dengan negative 38.96 cm. Okay, kenapa dapat negatif? Sebab dia adalah concave lens. So bila concave lens, dia punya focal length adalah negatif. So bila focal length negatif, dia punya type of the lens tu adalah diverging lens. Okay, let's say I tukar the position of the object. Dia tak duduk belah kiri, dia duduk belah kanan. Okay, dia duduk belah kanan, so R itu still lagi 50 di luar dan 15 cm di bahagian dalam. Tapi yang 15 cm tu dia akan jadi 15 cm tu dia akan jadi R1. Okay, 15 cm dia akan jadi R1, 50 cm dia akan jadi R2. Tapi sekarang dia bukan lagi positif. Okay, dia bukan lagi positif tapi dia akan jadi dua-dua negatif. Sebab apa negatif? Sebab dia facing concave surface. Objek tu facing concave surface. So jadi dia punya R tu akan jadi negatif. Alright, so jadi sekarang ni bila you saya tunjuk you the second option. So bila you substitute into the equation, you tetap akan dapat dia punya focal length itu negatif juga. Okay, dia tidaklah bila saya tukar the position of the object, dia akan jadi convex meniscus pula ke tak. Okay, so now here is 1 over negative 15. Okay, minus with 1 over negative 50. So jadi dia punya focal length dekat sini, you tetap akan dapat negative 38.96 cm, which is a diverging lens. Okay, now kita nak tengok pula macam mana kita nak guna equation 66. Okay, equation 66 and 67 for lens. Right? Okay, look at question 5a. Okay, 5a, an image is 15 cm height. Okay, image bukan object. Image is 15 cm height, is formed 24 cm behind the convex lens. Okay, as shown in figure 2. Alright, so kita keluarkan information given here. So you are given the height of the image which is equal to 15 cm. Tapi you nampak tak image tu terbalik? So bila image tu terbalik, as I mentioned before, okay, bila image tu inverted, dia punya height image tu negatif. Okay, bukan positif, dia adalah negatif. Alright, and then 24 cm behind the convex lens. Bila behind, okay, dia punya V tu bukan negatif lah. Okay, dia adalah positif. Don't get confused with mirror. Okay, ini adalah lens. So, jadi image yang terhasil behind the lens will be a real image. So, dia punya V tu positif. Okay, so the origin of the image is from an object 5 cm height located from the in front of the convex lens. So maksudnya dia bagi dekat awak H0, which is 5 cm. Okay, so calculate the object distance. Dia minta object distance U tu berapa. So according to the information given here, okay, information given dekat sini, awak nak cari object distance, awak nak cari U. Okay, so we can use equation 67 for us to find the magnification dulu. Okay, sebab daripada magnification tu we can find the U. Okay, so M sama dengan negative V over U and also equals to HI over H0. Okay, so kita punya V adalah 24 bahagi dengan U kita nak cari sama dengan HI which is negative 15 bahagi dengan our H0 is 5. Okay, kalau you salah substitute dekat sini V you akan U akan dapat negatif lah. Sepatutnya our object is always a real object which is positive. Okay, so U dekat sini you akan dapat sama dengan 8 cm. Okay, so our U is 8 cm. Alright, so lepas tu daripada situ we can find the focal length of the lens. Okay, because we already have U, you ada V, and then we can use equation 66 which is 1 over F equals to 1 over U plus dengan 1 over V. Okay, so 1 over U is 1 over 8 plus dengan 1 over V which is 1 over 24. Okay, so dekat sini you akan dapat the focal length equals to 6 cm. You mesti dapat focal length yang positif. Sebab apa? Sebab dia adalah convex lens. So bila convex lens, focal length dia adalah positif. Right? Okay, next question 9C. Okay, a converging meniscus lens. Meniscus lens. Okay, is made from a glass of refractive index 1.52. Okay, ini adalah refractive index untuk glass having a radius of 7 cm dengan 4 cm. Okay, sekarang ni dia adalah converging meniscus lens. So dia adalah convex lens. So jadi bila convex lens, dia bagi radius 7 dengan 4. Okay, so katakanlah saya lukis dia punya convex lens. So untuk convex lens, radius di bahagian luar lebih kecil daripada radius bahagian dalam. Okay, so please be careful with this. You jangan get confused with the concave meniscus. Okay, so untuk convex meniscus, radius di bahagian luar lebih kecil daripada radius bahagian dalam. So the radius dekat luar will be 4 cm. Okay, radius yang dekat dalam adalah 7 cm. Alright, so an object is placed 24 cm in front of the lens. Okay, so object located in front of the lens 24 cm. Okay, so dia suruh cari calculate the position of the image. Alright, so now kita nak pakai nak cari V kan. So you ada U, so kita nak pakai equation 66. But the problem is you don't have the focal length of the lens. So jadi kita boleh cari focal length of the lens dulu. So by using equation 69. Okay, kita cari focal length dulu. So for the first question, we use 1 over F equals to N material. Okay, lens 2 is made of glass, which is the index of refraction 1.52. Over dengan dia punya N medium is 1.0. Okay, sebab dia located dekat udara saja. So minus 1. Okay, darab dengan 1 over R1. Okay, so object is located, katakan dekat bahagian sini. Okay, dekat bahagian sini. So dekat bahagian kiri. So jadi R1 will be 4 cm and R2 will be 7 cm. Okay, tapi objek ni dia facing surface convex. So jadi convex dia punya radius adalah positif. Okay, so 1 over 4 minus dengan 1 over, yang ini pun surface convex. So 1 over 7. Okay, positif. Alright, so from that you can get the focal length sama dengan 17.95 cm. Okay, 17.95 cm itu adalah focal length of the lens. Tapi kalau pelajar dia lukis lens ni terbalik, Maksudnya terbalik dia ataupun dia tukar position of the object kat sini pun boleh juga. Dia tetap akan dapat focal length yang sama. So you punya substitution 1 over f will be 1.52 divided by 1.0 minus 1. Okay, 1 over R1. R1 you akan jadi surface concave. So here 7 cm. So will be negative 7. Minus dengan 1 over. Yang ini pun surface concave juga. Because your object is belah kanan. Okay, so dia akan jadi 1 over negative 4. Okay, so from here you akan dapat dia punya focal length sama juga 17.95 cm. Okay, tak kisah position of the object tu dekat mana. Okay, ataupun macam mana you lukis lens tu, dia tak kisah, dia tidak mempengaruhi. Okay, now kita dapat focal length. Lepas tu kita nak cari position of the image. So we can use 1 over f equals to 1 over u plus dengan 1 over v. So 1 over 17.95 equals to 1 over u. U is 24 cm. Okay, plus dengan 1 over v. So here we will get the v equals to 71.21 cm. Okay, 71.21 cm which is positive value. So bila positif, apa yang kita boleh dapat daripada nilai V yang positif? Meaning that image tu adalah image yang real. Bila real, dia punya partner dia adalah inverted. Alright, because the next question, dia tanya, is the image magnified or diminished? Macam mana kita nak cari image yang dia nak tentukan image tu magnified or diminished? By using equation 67, which is magnification equals to negative V over U. Okay, now you find we already have the V which is 71.21 divided by U which is 24 just now. Okay, so we will get the magnification is negative 2.97. Okay, apa maksud negatif tadi? Negatif maksudnya image tu adalah inverted. Macam saya cakap. Okay, so your image here is real. So real dia adalah inverted. Okay, so jadi dia proofkan dekat sini. Nampak tak? You dapat magnification negatif. Bila you dapat magnification negatif, meaning that image tu adalah image yang inverted. So sekarang ni dia tanya magnify atau diminish. So now your nilai magnification tu is more than 1, which is 2.97. So maksudnya image you adalah magnified. Sebab dia suruh justify the answer, so you have to show the calculation. Right? Okay, last but not least. Okay, ini adalah soalan tambahan. Because dalam you punya booklet, VIP tu dia tak ada soalan combination of two convex lens. So jadi saya cari satu soalan untuk kita solvekan question yang berkenaan dengan combination of two convex lens lah. Okay, so ada satu soalan dekat sini. Figure shows an object placed 15 cm in front of an arrangement of two convex lenses P and Q. We have two lenses P and Q. Focal length dia 10 cm dengan 20 cm respectively. So the focal length is positive. Okay, the lenses are placed 20 cm apart. So between P and Q, the distance is 20 cm. Determine the location of the final image formed by the lens. Dia nak final image form. Right, so jadi sekarang ni according to the information given, so you ada U which is 15 cm. Okay, and then you ada focal length yang pertama for P which is equals to 10 cm. Okay, the next focal length for Q is equals to 20 cm. So we have two focal length here. And then the distance between P and Q is 20 cm. Right, so untuk cari the final image form, kita kena buat one by one lah. Okay, first we do for first lens dulu. Okay, so we find the distance of the image produced by lens P. Okay, we will use equation 66, so 1 over f1. I label here f1 because of we are using the first lens. Okay, equals to 1 over u1 plus 1 over v1. Okay, 1 over f1. f1 is 10 cm. Equals to our u is 15 cm plus 1 over v1. So here we can get that v1 equals to 30 cm. Okay, positive. Positive meaning that, okay, the image form is 30 cm behind the first lens. Okay, so 30 cm, so jarak antara P dengan Q is 20, so meaning that here will be the location of the first image. This is the first object, so this is the first image. So the first image is 10 cm behind the second lens. Sebab jarak P dengan Q 20, so we have to add another 10 cm behind the second lens, so that will be the position of the first image. Okay, the first image will be the second object untuk second lens. Okay, so now the object is located behind of the second lens. So bila dia located behind of the second lens, okay, so dia punya U akan jadi negative 10 cm sebab dia duduk di belakang second lens. Okay, so kita akan guna 1 over F2. F2 pula sebab kita nak guna second lens kan, 1 over F2 equals to 1 over U2 plus dengan 1 over V2. Okay, so focal length yang kedua is 20 equals to 1 over U2 is negative 10. Okay, plus dengan 1 over V2. So V2 here, okay, we will get equals to positive 6.67 cm. Apa maksud positif? Okay, maksud positif adalah the image form is behind of the second lens. Okay, so this will be the final position untuk the combination of the lenses. Okay, so image 2 duduk di belakang lens Q, which is 6.67 cm. Macam tu. Okay, so I think that's all for today's session. Okay, so I hope I can help you. Okay, I give you an idea, okay, how to solve the question that related to geometrical optic, which is chapter 7 part A. Alright, thank you very much. See you next time.